Maybe some of you might be a little bit hungry, so let's get this done. So my name is Reyes. This is my face, and this is my Twitter handle. It's just my name without the E's, and I'm basically an occasional retweeter of tweets about JavaScript and stuff. And so if you're interested, come and follow me, and let's get connected. Also, I'm a freelance front-end engineer, mostly working with React and GraphQL. I'm also married, I play the guitar, and I like to be around the globe. If you haven't noticed, this background, this photo in the background, it's the place where I'm living, which is the beautiful city of Vienna, Austria. And by the way, if you ever have the chance to visit Vienna, please let me know. We have a great JavaScript and React community there, and we would love to meet and talk to you about everything. So now let's talk a little bit about code splitting. Hands up in the air, who haven't heard about code splitting yet? Wow, that's a few. Might be interesting for you. Who is code splitting and has a production app running with it? Hands up. That was quite a few. So what is the term code splitting all about? Code splitting is nothing but a feature that allows you to split code into multiple bundles, which then should be loaded on demand or in parallel. What does this mean in the component architecture of your application? Imagine this. As your dependency tree of modules or components of the application, the top level one represents the entry point, which imports two modules and so on and so forth. So most apps will likely define routes for their separate views. For example, the home route with its dependencies of other modules, right? And imagine this is your profile route, which has a total different modules as dependencies. So without taking advantage of code splitting, the bundler, like Webpacks, for example, usually creates one giant bundle that looks like this. All of your NPM packages, custom modules, and components are squeezed into one single giant bundle.js, one monolithic bundle, which can be really big depending on the application. So this means if you want to visit the profile page for only, for example, your whole code will be loaded, even the parts that are not needed or that are not executed. So looking at the dependency tree again, what we basically want is to define split points to take advantage of code splitting and cut its giant bundle.js into smaller pieces of chunks. So in this case, we define split points exactly there where our route-specific code starts. This exactly is the boundary between route-specific code and app-specific code, like our shared code. And after we've defined our splitting points, our application will be divided into several chunks. So in this case, we have our shared application code as bundle.js, representing one bundle and two other routes, specific chunks, home.js and profile.js, representing each a separate bundle. So imagine visiting your application in the home route. What we basically want is to only load code that's specific to the home route. Right? And in addition to this, the profile page should be ignored until we want to visit it. So code splitting allows us to dynamically load the code that is needed. It automatically determines what parts in our application that actual code will be, and what parts the dynamic added code will be. So looking at the bundles again, our app will dynamically load the code that we need based on our set routes, and potentially improve performance and reduce page flow. So you may be wondering, why should I actually care? Do I really need it? Somebody might say, my app is too small enough and fast enough. Yeah, I don't really need it. Isn't this just overhead? Of course, it's completely overhead for us. Looking into our internet speed test, we are surfing on a super high fiber power internet on maybe 100 megabytes per second. But the screen is obviously not from this conference, by the way. Of course, we are all engineers. We know how we get to a fast internet connection. We are privileged, and most of the time we don't have to worry about accessing our web applications. Well, almost, until we somewhere else are on a slow 3G looking into a widescreen like this. And everybody hates this, especially when you need to wait forever until you see something. And it's the worst feeling ever. Imagine you being somewhere in the middle of the jungle, and you're used to expect internet to just work. So in fact, we're living in a world where a vast majority of people don't use giant computers anymore. It's likely that more and more people will use web applications with their smartphones, but every day. So to get back to the question, why should I care? Well, CodeSplit can help out here by reducing your idle time, and despite the overhead of writing additional code and get split up bundles, is because it's so simple to do that. Code splitting doesn't mean that you need to refactor 30 or 40% of the application. No, it's literally replacing one line of code with 4 lines of code, and that's basically it. That's only 3 more lines of code for grammatically improving your page speed. Now, how does code splitting actually increase performance? One important topic of why I want to code split is long-term caching. The basic idea of long-term caching is to split your vendor code, like packages in node modules that almost never changes, with application code where you frequently update and add features over the time, right? So with caching, you basically get the benefit of not re-downloading NPM packages that hasn't changed. So split up code are being downloaded asynchronously using the power of promises. This means you don't have to worry about render blocking due to page loading. Instead, you could render your loading component until the async component has been loaded and is ready to be rendered. With code splitting, we load our code on demand. If we asynchronously load code, that it's being injected automatically to the DOM. This means we don't have to worry about things happening there. Also, we don't want to waste any kilobytes that's being downloaded through the network that we don't need on our current page or view, right? So what we really want is we want the code load as needed. All this is possible with the power of code splitting. Some might be curious. So let's take a little closer look of an example on how code splitting actually works. So imagine our app example earlier. We're having our home route with a blue content background and a profile route with the pink content background, which I will show you a little bit later. So when we visit our application with the home route and take a closer look in our HTML element tree, we'll notice 2 script tags. One that has been appended to the body, which is the bundle.js, and represents our shared application code. And the other one is home.chunk.js, which represents the route-specific code, which you see here in the head. And this one has been created dynamically as we visited the route. We as developers don't have to worry on how to dynamically create those script tags. This is handled by the bundle itself, which is, in this case, Webpack. How many of you guys use Webpack, by the way? Hands up in the air. Oh, that's quite a few.
How many dozen?
How many dozen?
Why?
Why?
Check it out.
Nobody knows. So being on a home route, we want to visit the profile route. And to do so, we click on the profile link, which I have highlighted here in red. So as we click at the profile link, we notice the background of the content turns pink to just visually indicate that we are on the profile page, right? And looking back to the HTML element tree, we notice there is another script tag. Now there are 3 script tags in total. It's because the script tag for the profile page, profile.chunk.js, has been dynamically added to the Webpack bundler, by the Webpack bundler. And this is really powerful. Webpack doesn't just allow you to split your code into multiple chunks, but it also loads these chunks dynamically based on user interactions. We as developers don't have to worry about appending script text to the DOM. Now, how do we actually split code and how does the syntax look like? Well, there are a number of ways on how to import modules in your own module. So there's system.js or system.import, common.js requires or require ensure. Some people even implemented their own custom way of importing modules. But to be honest, we can do much better than this. Introducing this dynamic imports. So dynamic imports have arrived, right? It looks exactly like this, and it's really awesome and very familiar, especially for us JavaScript developers. So what is it and how do I use it? Dynamic imports look syntactically exactly like a function, but it uses the reserved word import as the name of its function, and it accepts the path module and loads the module or component asynchronously by returning a new promise. A lot of popular open source libraries are adapting this feature already, as the syntax makes so much sense. So let's take a little look on how the status of the feature actually is. Well, as for today, it's still an open TC39 proposal on stage 3. If you're interested in the progress, definitely check out this GitHub repository. You can follow along our discussions or open new one around this topic. But of course, we don't have to wait until this to land to the new ECMAScript specification or JavaScript spec. Because with Babel, we can use it. We can use the syntax today. We don't have to wait until next month or next year. By adding this plugin to your configuration, Babel will able to parse the new syntax into code that is readable in your browser or any other target environment you use. So the magic with dynamic imports, the dynamic script tags will be handled by the bundler, which is Webpack in this case. There are fantastic guides in the Webpack documentation on how to set up and use code splitting. Also on survivejs.com by Juho, you will get a great step-by-step guide on how to set up code splitting with the dynamic imports. So these are two sources I highly recommend if you intend to code split your application. And of course, Webpack is only one of many other great bundles. Most of the other supports probably this feature too, or anytime soon. Now let's talk a little bit about more about on how dynamic imports are different compared to synchronous imports. So basically, EU6 imports or common.js imports loads modules synchronously using the syntax. After importing your module or component, you can directly access your module right after you have imported it. So it's nothing new, right? But guess what? Remember what it was like in the past? EU6 imports after using common.js imports for a while. So it was exactly like this. So with dynamic imports, you will be able to load modules or components asynchronously by returning promises. Accessing the results just works just exactly like with promises. So of course you can use dynamic imports with the new async and await. The huge benefit of it is you write asynchronous code that looks like it's synchronous, but it's actually async. You simply add async to the wrapping function and add an await right before you import. And after this, you can access the resolved module as usual, as you would do it in a synchronous way. Now it's probably like the same feeling, but with dynamic imports. But I don't think it will be replaced by sync imports anytime soon or anytime, like EU6 and common.js imports. So let's take a look on how we leverage code splitting in our React application. Note that you can apply the basic idea to any other frameworks you're using, like Angular, Vue, or Ember. But for now, I'll show you an example on how it's done in React. So in React, we have our app component, which should simply load a separate React component asynchronously once the app has been rendered. So if you would open our app in our browser, it should load any random async component right from the start. In our component, we define an initial state called async component, which is, in this case, a function by default, returning a div element that indicates that nothing is loaded. So React CF components has this pattern called lifecycle hooks, like component did mount. It will fire when the component has successfully mounted. So in component did mount, we call the dynamic import function and pass to our async component as an argument. After we have received it, we simply assign it to a variable, which we have called async component, and in this case, pass it to our state by calling the setState function. So because we have changed our state, the component will perform a re-render and show our newly added async component. So the render function will either return nothing loaded in the killer or the async synchronously loaded component. But what about multiple components at once? Well, for this, we can take advantage of using this promise.all. It's just the same thing like we already do with promises. So it works like this. In the component did mount lifecycle hook, we call promise.all, pass an array of dynamic imports which resolves components directly. As a result, we get an array of all resolved components. So in our render function, we simply map through the array and render each component one by one. You probably might be thinking, wow, this is a lot of code, and this doesn't look like 3 lines of extra code you mentioned earlier. Are you kidding me or what? And yeah, totally, I'm kidding. So there's an open source library like React Loadable that cuts it down into a few lines. So React Loadable by James Kyle is a higher order component for React that basically takes all the complexity that I just explained to you before and makes using dynamic imports even easier. It has everything you need for code splitting or for splitting your code asynchronously, including support for server-side rendering. Here's a quick example of comparison with a route. In this synchronous way, we would pass in our route element the home component, which is syntax highlighted here in red, with the component prop. And with React Loadable, we basically replace this home component, and with a React Loadable higher order component, and pass an object with a bunch of options. So in this case, it's loader, which is a function that returns a dynamic import, and a loading option, which is just a component that should just be rendered while the async component is being loaded. So that was only 3 more lines of code, or maybe even less if you want to. And just with this little amount of extra code, you can potentially increase the page speed of your app up to 5 times. So React Loadable works also great with Create React App, which already takes a lot of work from you. So Create React App is a great way to start React App with 0 configuration. And with Create React App, you can start using dynamic imports right away without configuring anything. So especially if you're new to React or about to start a new React application, it's definitely worth to consider it. But maybe some of you might probably be like, Create React App is not an option. We need server-side rendering for our application. Of course, open source force got you. Next.js version 3. It has been released just more than a month ago and supports code splitting and dynamic imports out of the box. It has a very minimalistic API, and it renders your app completely on the server too. So it's probably the greatest framework in the open source community or in the React community, especially if you're looking for something that supports server-side rendering in combination with code splitting from the beginning. So Guillaume Ralph, which is the author of Next.js and of many other great tools mentioned on Twitter, Site.co itself, of course, is built with Next.js and uses hundreds of code splitting entry points. Since then, they have split up their web app into several smaller chunks and reduced boot up time of their app from 1,000 milliseconds down to 200 milliseconds. Well, when I started to dig deeper into code splitting, I saw so many guides on how to do and what it does. But in reality, I was actually more interested in how do I make it right? What are the common practices? And how do I successfully make an app faster by using code splitting? So I would love to share you an approach of applying these common practices to strategically code split your entire application. First, besides dynamic imports, you may want to split your app and vendor code to get the benefit of long-term caching, as I've mentioned before. So create one bundle for your vendor code of node modules and another bundle of your frequently updating code or updating app. My friend Andre, who will also be speaking today, did a great job on explaining exactly this problem in a Medium blog post. So definitely check this out to get a basic understanding on how it works with the Webpack and on what the most important advantages of using long-term caching are. I'd also recommend a more recent Medium blog post by Tim Sebastian. He basically treats the problem of named chunks and named module IDs. So definitely worth consider reading it, especially if you want to leverage caching of your app and improve understanding of long-term caching. So second, consider splitting your code at route level using dynamic imports. Every single line of code of page you visit typically belongs to a page. So in general, it's a common practice to split your code at the route entry points, even if there might be probably a chunk of code that can be shared. For this, Webpack introduced an awesome feature called named chunks. So with Webpack chunk names, we're able to assign a name to our chunks, to group certain split codes together. So and also besides naming these chunks, it allows you to organize and group multiple asynchronous modules to a same named chunk. And it's pretty neat, especially if we want to use a shared code, especially just for parts of the app. And after splitting vendor with app code and splitting app code further down by the routes, consider splitting your code further down at component level. For example, if we have a huge chart on a page, you probably might want to lazily load it as the user scrolls this chart into his viewport, like into his screen. So this way, we don't wastefully load components that is outside of the screen and not being displayed in the browser. Of course, we should not overuse dynamic splitting points, since this can also have a negative effect. But for such examples like this chart, it's definitely worth to check out the overall page speed impact. Also, try to predict what the user intends to do in the app and prefetch based on user interaction. Sometimes there are use cases where users most likely will click on certain things, and therefore you can prefetch these chunks so that the code is already there and prepared until the user finally switches to the view. So to sum up, where to split app and vendor code for long-term caching, split at the route level asynchronously to load only code that is needed for the page, split at component level to lazily load parts of the app as the user scrolls into it. If you're interested in code splitting benchmarks and page load performance, here are also really great, interesting resources around these topics that I found pretty useful during my research. So they might be interesting, so I highly recommend these articles. I'll share my slides right after this talk, I guess. All right. Awesome. Now that we have learned so much about code splitting, so let's get our hands to the editor and make the web faster. Just not for us, but for everybody. But maybe after lunch. So to recap this talk, dynamic imports. Despite its TC39 proposal, you can use it today with Babel. Make sure not to load useless code by splitting your code with dynamic imports. Depending on the size of your project, will reduce your page speed up to 5 times. First, split app and vendor code, then at route level, then at component level. And create a React app in Next.js fully support this feature and are great ways to start. And yeah, if you're interested in the code splitting of your app, come find me and talk to me, or find me on GitHub or Twitter. And yeah, that's all I got. Thanks very much. Enjoy lunch.